Hello everyone, welcome to the second tutorial on OpenCV. In the first tutorial we learned how to load images and process them through simple modification changing the color space. In this tutorial we're gonna learn how to do a bit more complicated tasks. We're gonna try to plot a histogram of an image and also try to use that to threshold an image, basically perform a simple segmentation task. Some of the concepts that we have talked through the course. Let's begin. So it's the same folder. I just have added a simple image that we're going to work on today, this image, and you can download this from the Learn web page under the tutorial section if you want to write your own code. I'm going to create a new file. Let's call this histogram. First we have to import the OpenCV module, and we're gonna also use the matplot library to plot the histogram, so we import matplot library as well. Let's read that image that I've added to this folder first using the imread command. The image itself is grayscale, so we're gonna load it as grayscale. Let's plot the image. So we now have that image, and we want to plot the histogram for that image. If you remember, a histogram is a plot that shows how many pixels have a specific color value. For instance, if we have a grayscale image that 50 of the pixels have the color of 100, which means it's almost between white and black, then it shows in the plot that for that specific color we have 50 pixels. OpenCV has a command to calculate the histogram very easily. It's called hist command. The command is actually calc hist, and it takes 6 inputs. The first input is the array that contains the image. The second input is what channel in that array we want to use to calculate the histogram. If you remember, for a grayscale image we have only one array, one channel. But if you had a colored image, we would have 3 channels in an array. And if you wanted to calculate the histogram of, let's say, for a blue color, we use channel 0. If you wanted to calculate the histogram for green color, we use channel 1, and for red we use channel 2. But we have a grayscale image, so we just have one channel. The third input is the mask we're gonna use. I'm gonna talk about it later, but for now we don't have any masks. And the next is the size of the histogram. Obviously we have 255 different shades of gray, so our channel should contain 255 points. The size is from 0 to 256. And what range of colors do we want? We want it from 0 to 256. We want all the different combinations of different shades of gray to be included in the histogram. And the output of this would be hist. Let's print to see what it is. It is an array with the size of 255, and each one shows the number of pixels for that specific color. For instance, the first one shows the number of pixels for a grayscale color that corresponds to 0. So for purely black, for pure black color, we don't have any pixels. Then a shade lighter, we have 17 pixels. A bit lighter, we have 24. So this shows number of pixels for each value inside the image. Now we can plot this as well. Let's plot the histogram. Sorry, the limitations are for x-axis only. So this is the histogram for the image we saw. Let me open up that image again. So this shows how many pixels each color value has. If you can see, there are lots of white in this image, right? Lots of bright spots in the image. So the number of pixels for bright colors in the range of about 150 to 250 is a lot. So most of the pixels are in the light gray scales, and we have a few black spots here. So the main block that's in the middle is very dark, so we have some pixels that are black, belong to the grayscale between 0 to 50. Histogram is a very nice tool that gives us a lot of information about an image that we can use to threshold an image. For instance, if we wanted to only select the dark object inside this image, all we had to do is cut the image from here and show the pixel values that are below 100, let's say. Then we could separate this block from the rest of the image. Also, it gives us some information that can be used to say, for instance, if an image is fake or not. Real images usually don't contain pure black color or pure white. Usually if an image is modified or processed by some algorithm, if it's enhanced, then it will contain some different pixels that are purely black or purely white. If you see, this is a real image, so the number of pixels that are purely black at 0 is 0. The number of pixels that are purely white at the end are 0. So we can guess that this image is a real image. We don't have pure black or pure white colors. That's some other thing you can learn from histogram. We can also plot the histogram for colored image. Let's plot the histogram for this colored image that we have here. You have to load it as a colored image. Then I want to plot histogram for all different channels. Let's plot the first channel. It is blue. We plot it with color blue. Second channel is green. Third channel is red. Remember, in OpenCV the coloring code is BGR. Let's plot the histogram. So the image was JPEG. I forgot to input the format. So this is the histogram for the 3 colors that we have. See, it has lots of green in the shades in the middle, blue, and it has lots of bright reds at the end of it. You see, the colors that are purely red are quite a lot of them. About 17,000 pixels are very bright red. And this can tell you that, for instance, this image has been modified. There have been lots of color noise added. That's why we have quite a lot of dark reds. But essentially you can use histogram to plot histogram of colored images as well. Another thing in histogram we can do is using a mask. I did not use any mask in the images, but you can use a mask to plot a histogram of a specific part of an image. Let's go back to our previous image. I plotted the histogram for the whole image. Now assume I wanted to plot a histogram for a specific window inside that image. For instance, assume you have an image with this size. Let's say it is 300 by 400 pixels, and it has an image inside it. You want to only calculate the histogram for a specific window inside of it. You need to create a mask that separates this window from the image. And the way we do it, we create an image with the same size as the original image and only set these pixel values to white and make the rest pure black. Then when we give this input as a mask to the thresholding algorithm, it will only give us the threshold values for this part. Now let's try it in the code. I'm gonna create a mask first. So the mask has the same size as the image, but it's just black everywhere. And remember, it should be unsigned integer. It's similar to the image. So all values are 0, so it's black everywhere. Then I change some of the pixels inside of it, the ones that I want to calculate the histogram for, into white colors. Now we can see the mask itself as well. This is my image, this is my mask. Now let's plot the histogram for the mask only. So I would use the mask to calculate the histogram. So the histogram is now a bit different. There are fewer pixels in it, and it only shows very specific part that I wanted inside the mask. These masks are used a lot in the image processing inside OpenCV. If you want to separate a specific window inside an image, we always use a mask. Now that we know about how to plot a histogram of an image, we're going to talk about thresholding. So we talked in the course, thresholding is a simple way to segment image, separate pixels that have similar color or similar shades of color from the rest of the image. For instance, if you see an object that has a specific color, you can use thresholding to separate it. If you look at the histogram again, thresholding is very useful when a specific part of the image is separate from the rest of it. For instance, in our image, we have lots of points that are very dark and lots of bright points. So if we want to separate the background from the black object, we can easily use thresholding. All we have to do is separate the pixels at the point in the middle of these two peaks, like here around 127. Now let's use thresholding in OpenCV. The command for thresholding is cv2 threshold, and it has two outputs. The output of image of a thresholding algorithm is the thresholded image, the image that we have thresholded, the output image, and a retrieved value which shows the value that is used for thresholding. There are different methods for thresholding that I'm going to talk about. Some use adaptive methods that would adaptively identify the threshold value for you. Then the output would be different from what you set as a threshold value. But the inputs for CV threshold. The first input is the image array itself. We have the image. The second input is the value that you want to use to threshold the image. In the histogram, we saw that somewhere around 130 was where the background was separated from the object. So we use this value for threshold. And then we saw the maximum number of the pixel value, which one we want here is 255. So we want a threshold between 130 and 255. And then the method used to threshold. There are different methods. Some methods are adaptive. They use different Gaussian methods to identify the proper threshold value. Then the threshold value that you're given is just a starting point for the algorithm. I'm not going to talk about those. I'm going to talk about some basic thresholding methods. The first, simplest way is using a binary value. Threshold binary basically turns the ones above these into white, the ones below it into black. Let's see how it works. This is the original image and this is the thresholded value. So it turns the image into a binary image, black and white, and separated the object from the background based on the threshold value that we gave to it. Let's try another method. Binary inverse. It changes the color of black and white. Previously the object was pure black, the background was white. Now it does the inverse. Another method is use a mask. We haven't defined a mask. You can define a mask to threshold based on the mask. There's also threshold to 0. So you see the objects that have a color value below the threshold that we defined were turned into pure black. The rest were kept as it was. So the rest didn't turn white. That's threshold to 0. You can do inverse of that as well. So the objects that are above 130 now turn to pure black. The rest remain. So these are different thresholding methods, but they're essentially the same. The one that's most common and used is threshold to binary. You want to separate the object from the rest. And if we print the threshold image, you will see that most of it has turned into white and only the object has turned into a pure black color. And that is the most of the topics I want to talk about for this tutorial session. We saw how we can plot histogram, how we can use histogram to threshold images and separate an object from a background. In the next tutorial, I'm going to talk about how to read videos and process them. So far, we've been talking only about images.